Several people asked me, how do I deal with a three-variable problem? So I thought I would model how to do it. And you can approach it in a few different ways, but the basic thing is you want to systematically get it down to two variables first, so then you have ultimately two equations that are in two variables, the same two variables, so that you can use the elimination methods like you already know how to do. It just takes a little more time. So what I'm going to do is I'm going to look at these equations. I'm finding, well, I could deal with x's, I could deal with z's. Y's are going to be a little harder, so I'm going to focus on the x's. So what I'm going to do is I'm going to take these two equations, and I'm also going to take these two equations. I'm making two little combos. Okay. And with these two equations, I'm going to need to get the x coefficients the same. So the way I'm going to do that is I'm going to multiply this entire thing by 2, because that'll double all of these and they'll have a 2x. So that's going to end up being 2x minus 6y plus 4z equals negative 10. And my other equation just comes over. And then I can subtract. So I'll subtract, because if I subtract, 2x goes away. It's 2x minus 2x, and I'm left with negative y minus negative 6y, so that's 5y. And 3z minus 4z is minus z. And 11 minus negative 10 equals 21. So now I have an equation in two variables. I'm going to do the same stuff to this one. Oh, but I made a mistake. I could do it this way, but I'm going to hate on that one, and instead I'm going to bring this one down because I get to do less work. And the reason I did that is this time I only have, if I'd used the 2x, I had to multiply the top one by 2 and the bottom one by 3. This way I just have to multiply this bottom one by 3. So I'm going to do that, and I'm going to get, oops, put that 3 in the right place. The bracket was backwards, so it's 3 times everything in that equation. So I've got 3x minus 9y plus 6z equals negative 15 this time. And this one will become same as it was. And now I can have two x terms that have the same coefficient, so I can just subtract. And I will do that. 3x minus 3x is nothing. Negative 7y minus negative 9y is 2y. And z minus 6z is going to be negative 5z. And negative 25 minus negative 15 equals negative 10. All right, now notice I have this and this. I have two equations and just two variables. So I'm going to copy this one here, and I'm going to copy this one. And I'm going to get to work on them. All right, so this time I'm going to have to do something to get the same coefficients. So I'm going to, if I want to work with the y's, I'll double this and quintuple the bottom one to get 10y and 10y. But instead I'm going to focus on the z's because I can just quintuple the top one and I don't have to deal with anything with the bottom one, any multiplying or dividing. So 5 times that will get me 25y, 25y minus 5z equals 5 times 21 is 105. And this one stays the same, 2y minus 5z equals negative 10. Now, I have the same coefficients for z. I'll just subtract. 25y minus 2y is 23y. Negative 5z minus negative 5z is 0. That becomes 105 minus 10 is 115. Okay, now I'm going to divide both sides by 23. 23 divided by 23. And now I've got y equals, well, 115 divided by 23 is 5. Now I can go back and I can replace things with y with 5 in all the equations if I want. But I'm going to go ahead and deal with the y component. Actually, I'm going to deal with the z component. I'm going to get rid of y. Actually, no, we'll just solve for y because we have what we need. So I'm going to copy this. I know y equals 5. So I'm going to replace y with 5 and solve for z. So that's now easy to work with. So I've got 10 minus 5z equals negative 10. I'm going to subtract 10 from both sides. I'm going to get negative 5z equals negative 20. I'm going to divide by negative 5 on both sides. And z will equal 4 because negative 20 divided by negative 5 is 4. So now I know y is 5, z is 4. I can go back to my original equations. Y equals 5, z equals 4, and I need just to get x. So I look at these, and I'm going to use the one that has x all by itself, and I'm going to work with that. So I replace y with 5 and z with 4, and I solve. I've got x minus 15 plus 8 equals negative 5. Get rid of that typo. Negative 5. And now I've got add 15 and subtract 8 from both sides. Add 15 and subtract 8 from both sides. I get x equals negative 5 plus 15 minus 8, which equals negative 15. Negative 5 plus 15 is 10. So that's 10 minus 8 equals 2. So x equals 2. And that's my solution for that problem. It actually wasn't as hard as I thought it would be. And it's all about keeping track of your players and working systematically.